Today, I want to talk about how to solve equations involving sine. So let's get into it. Let's say we have something in the form sine x equals a, and we want to solve for x. What does x equal? Well, we'll have two different branches of x. X will equal sine inverse of a plus 2 pi k, and x will equal pi minus sine inverse of a plus 2 pi k. And k equals the integers. That's an important fact to always write down. So that way people know what you mean when you're talking about k. And by the integers, I just mean k can equal 0, positive or negative 1, positive or negative 2, and so on, right? So let's erase this, and let's do some problems that look just like this to begin with. So let's say we have sine x equals 1. Sine x equals 1, right? What does x equal? Well, x equals, once again, we'll have two branches, and we'll start with sine inverse of 1 plus 2 pi k, and pi minus sine inverse of 1 plus 2 pi k. All right, and now we want to begin to evaluate sine inverse of 1. Well, what is sine inverse of 1? Sine inverse will always return us an angle. What angle of sine gives us 1? Well, that's pi over 2, right? So then we can say x equals pi over 2 plus 2 pi k, right? And let's not forget to mention what k means. K equals the integers, right? Now I'm going to need to write that down both times. Then here we have pi minus pi over 2 plus 2 pi k, right? But if you notice, these two are the exact same thing. That's not going to happen all the time, right? Most of the time you will, in fact, have multiple branches. But in this case, both of these are the same, right? Because as you can see, pi minus pi over 2 equals pi over 2. So we can just then say x equals pi over 2 plus 2 pi k, and then k equals the integers, right? That's always an important fact to write down. Let's do something a little bit more complicated, right? We'll just change it a little bit. Let's now say we have sine, let's sit here. We'll do sine inverse 2x equals 1, okay? Now what do we do? Well, we have 2x. So you'd think that would be a problem, but it's not a problem. Now, instead of x, we'll just have 2x equals, and we already know what that will be before, right? It'll be pi over 2 plus 2 pi k, right? Where k equals the integers. That's what we had before. Then we can just divide this whole thing by 2, right? And we get x equals pi over 4 plus pi k, where k equals the integers, okay? And that's what we have here. So now our solution's a little bit different, but we had the same process when we had 2x rather than just x itself. So don't get startled by having 2x instead of x or any other number there. It's going to be the same process, okay? Now, let's say we have 2 sine x cosine x equals, let's say we have sine squared x plus cosine squared x. Now, you might look at this, right, especially if you're just getting an intro, and you might get really startled, right? We have sine, cosine being multiplied together, and then we have a sine squared x and a cosine squared x, right? That's a lot going on in this problem. But if we take a look at our trig identities, what do we notice? Well, sine squared x plus cosine squared x, that just equals 1. And 2 times sine x times cosine x, what does that equal? Well, that equals sine of 2x. And that's exactly what we had before, right? I'm not going to solve this again. You've just seen what it was, right? But as you can see, when we have these big expressions that look scary to us, most of the time they can be simplified down to something very nice to work with, and we've already seen this exact thing before. It's just in a different form. So once again, don't get startled by things like that. Okay? Now, I want to talk about one last thing. Let's say we are working with, let's say we have sine x equals 2 sine squared x plus 2 cosine squared x. Well, let's try to solve it just like we did before. But so we start off sine x equals, let's factor out 2. We get sine squared x plus cosine squared x, right? Now, we know this equals 1, so that's 2 times 1. So we get sine x equals 2. Now, we try to solve it like we did before, and we get x equals sine inverse of 2, right? Plus 2 pi k, and we get pi minus sine inverse of 2 plus 2 pi k, where k equals the integers, right? Except we have a problem here. Sine inverse of 2 doesn't exist, right? The range of sine is from -1 to 1. So there's no sine inverse of 2. Therefore, there's no x that we can put into sine that will give us 2. Therefore, this has no solution, right? This problem has no answer. That's stuff that you always need to be out on the look for when you're solving trigonometric equations. Thank you for watching. Let me know if I say anything wrong or if you have anything additional to add. Have a great day.